context on how we need to present this to you voters. How many people here have actually implemented PODS, as in executed the scripts to create a database on their server? Okay, so a couple people have gone through that. How many people have visited the PODS website and looked at the materials out there? All right, and I guess most people sort of are involved in the GIS spectrum. I mean, that's your main line of business, pipelines and GIS. So, by and large, yes? Okay, good. So, we'll talk about things. If we say something and it's like totally, completely flunked, you just throw your hand up. We'll answer it, or we can table it to the end, one way or the other. All right? Okay, so really what we're going to talk about for 45 minutes is the PODS model itself, the idea of data models, why we need them, why we use them, the design philosophy behind PODS, talk a little bit about the history of PODS, particularly with the parallel efforts in the ArcGIS pipeline data model, APDM. Then we'll dive down a little bit into the components of the model, why it is the way it is, and what it's supposed to capture from a pipeline perspective, linear referencing being a big part of that. Talk a little bit about some of the higher level design elements in terms of how the model is organized. You can see over in the back that we've got new logical model posters or entity relationship diagrams. It's worth just looking at there to find out how the main categories of the model are sort of grouped and organized together. And then we'll talk a little bit about some other additional web resources that are out there. Of course, anybody wearing the very cool black pod shirt with the, that's not a rock star, or Hawaiian shirt. Talk to anyone dressed like that. Find someone else with a Hawaiian shirt and just accost them and see if they're actually on the committee. But all those people are available as resources for you to talk to and ask questions of. And don't be shy. That's why we're here. So go ahead with that. Okay, so to start this whole conversation off, I want to add an additional slide to the presentation and just apply the journalistic thrift to the idea of data models. It's really the who, what, where, why, and when. I mean, who uses a data model? Typically, people want to use a data model because it's been developed with industry best practices and standards. So it is a logical organization of abstract concepts, which is a mouthful, but when you break that down, it's logical, so you understand it. Organization is put into groups and buckets of abstract concepts. We don't actually put a pipe into a database, but we represent it abstractly in a table as a record. And that's really the whole principle behind a data model. It's a logical organization. So what they hold are records in its deepest, lowest level. It's a database, and it holds records. And each one of those records represents an object in the real world. So computer people are really fond of the term abstraction. And we abstract things all the time. There's so much information. There's so many things. We have this incredible brain that allows us to see the world, but we abstract it into concepts that help us with understanding. That's really what a data model does. Break it down to a row that you can query again to give you meaningful information and help do what you need to do, which is your work. Seems like a very, very obvious concept, but really, when we're here about PODS, you look at this slide, and this is really the only thing you need to know about. This is why we have it. This is why we built it. This is what we've done, okay? So where are they hosted? PODS is designed to be used in the enterprise. Okay, so when I use that term, I mean it's going to be put on a server of some significance in a relational database management system, typically built by vendors like Oracle or SQL Server. Okay, so that's sort of the context. When we look at a PODS database, it's available to the enterprise. And I think this is really important, because why are you putting this stuff in? Not to guard it like this. We've all got these little devices now that let us tap into resources all over the place. We want to put it into a database and make it available for everybody to use. And that's really what this organization is about, to build standards to put this thing together. Okay? Well, why do we build data models? Well, there's a couple of reasons. You notice the S part in the PODS world is standards. Organizations say, I'm not going to spend any money unless we do this in a standard and approved and recognized paradigm. So we must adhere to a standard. That's not necessarily this is the law and you will obey it, but this is something that has been proven, has a track record. Look at the amount of people here about PODS. So that's one of the reasons why. The other one is I need to store this information. And I think if you read the keynote yesterday, the big takeaway I got this is Robert's one comment that really jumped out at me is regulators don't just look at data, they need to see it. Okay, and the number one reason for anybody to implement this is to be able to prove in an audit that you're doing what you're supposed to do if you have a pipeline in North America. Okay, really the number one reason, and I think they very eloquently said this, is we are managing our data so that we are saving lives. Pipelines are very volatile, they can explode with a big consequence. So using the standards, using best practices implementation to run your business, but also to prove that you are doing what you should be doing is critical to it. And when? Well, people put it into place when we need to build a GIS that tie a variety of systems together to give you a holistic picture of your entire business. I think that's pretty much it. So that's what we're doing. So that, now we'll dive into some of the details, but I think that's an important way to present the context of what we're doing and why we're doing it. Okay. Over the last 14 years, the PODS model has gone from something fairly simple to something very, very, very complex. There are a lot of tables. There's a lot of data. There's a lot of organization. One thing we're very excited about now is people look at PODS up until literally this conference and said, really? There's 700 some odd tables here. Do I have to use them all? Well, not anymore. If you stick around for the next presentation, Christopher and I are going to talk about modularization, which is really nice because we've broken PODS down into elements that you can use as you need to. So over time, it has, on a regular basis, incremented its versions. And I think this is important to show that within the PODS organization, we are making regular progress, so that you can expect a new release of the model every year with the latest innovations of what's happening in the industry. So originally, the PODS model derived from ISAT, and I think really it started off with 63 tables. And as the demands and regulatory requirements of the industry came into play, and data was made available to GIS practitioners in business, particularly from inline inspections and physical inspections where actually excavations happened against the pipeline. More and more tables were added significantly. You can see that almost there was an exponential growth in the amount of tables to store the information that people were starting to collect. Again, the model always sort of goes through an evolution where things are improved, new technologies are added, particularly the advent of globally unique identifiers. Okay, globally unique identifiers are a 38-character string that, based on the MAC address of a computer and an algorithm, generates a theoretically completely unique identifier, which means that every asset, every record in your database could have its own identifier, okay? Regulatorily, the model was expanded to support high consequence areas and support for, in North America, the National Pipeline Mapping System. And again, the inline data model was added and improved. Over the year, again, another term you will see in data modeling is the idea of normalization. Data models are a challenge, because we go back to that abstraction idea. I have reality, I have a data model. How do I distill reality down to the data model? Well, that process is called normalization, so that in a logical fashion, you can query that database to pull data out. So that kind of work is always going on. We're always sort of tweaking and looking at the data model to improve it, to make it more efficient, but also adhere to the laws of how databases are designed. As a Todd is the sort of father of the rules of a database. And the real simple rule you need to understand without getting into the technical details is every column in a table must refer to the primary key. It must describe that entity, and that entity alone. You can't have a pipe and then have some information about a valve in the table. That breaks what's known as the third normal form. And I think it goes as every item in a table must support and describe the primary key, the whole primary key, and nothing but the primary key, so help you God. And so that idea of normalization, so if you see that term, please don't run from the room screaming. Say, they're talking about fish. so how does the model change? Really, the idea is that members can go and provide input. Okay, members can provide. Members, people who are part of the PODS Association can go provide input. Okay, then this information is filtered to the board, and the board comes up with a plan for the next 6 months, 3 months, year. The board and the technical committee sit down and we arm wrestle it out and say, yes, this is appropriate, because there's some back and forth between the board. The board's looking at things strategically, and the technical committee and all the working groups associated with the technical committee are looking at things tactically and how do we actually write the code to make it happen, and how does it actually work. And so there is some feedback back and forth between those two organizations. Okay. So once that agenda is hammered out, the technical committee and the board come up with a scope. The board approves it. The technical committee goes out and researches it. They do the data modeling. They document it. They test it. They release it for member comment, and they come up with a complete package. Again, the next presentation will talk about the modularization package, and we will be able to show you an example of the results of one of these working committees. We respond, the technical committee will respond to member comments, and again, I want to dive back for a second. Both Christopher and I are members of the technical committee, and we both, well, Christopher is the chairperson of the data modeling team, and that's the team that's primarily responsible for changes to the fundamental elements of the database itself. Once everything has been revised, it's then sent and it's approved, and it becomes part of PODS. And the previous slide showed you that over the years, major and minor revisions to the database have gone on and occurred. All right.
My turn now?
I need a
break. Okay, here. Okay, so my name is Christopher. PODS is built on this thing called linear referencing. And for those of you that don't know me, I'm kind of young and relatively young in this industry especially. And when I came here, I kind of looked at this thing and I said, why on earth are you doing this? And it was explained to me that we had to have distance from the beginning of the pipe, and we have to have survey, and we have to have all of this and that. And I was kind of like, well, if we have to. So we have this concept of linear referencing, right? So we have to be able to survey our pipe. So I got to start at the beginning of it somewhere, and I got to be able to walk down that pipe a certain distance, and I have to be able to say, okay, I've gone 524 feet, and hey, look, this is my valve, right where it was supposed to be. And there's nothing. The animations are killing me here. So, or 500 feet according to the slide. So the idea of linear referencing is the thing that says, oh, starting at the beginning of my pipe, I'm going to go a distance, and then something is going to be there. And it might be a linear thing. It might be like a piece of pipe, or it might be a casing that goes across a road, but it's going to start at a place and it's going to end at a place. And so one of the things that PODS as a model has to do is manage this linear referencing. So we have to be able to store with each feature where does it start and where does it end. Basically, its location, but not necessarily its location on the Earth, just its location relative to the pipe. I think I got ahead of the slides. Anyway, so that's what I was talking about there. So you can have points or you can have lines that represent things on my pipeline, and those are abstractions like Pete was talking about. So I might have a valve on my pipeline. That physical valve might be 4 feet long. It might be gigantic. But in the database, I'm just going to say that it's a point. It exists at exactly 500 stationing. Or it might be a casing that goes 50 feet across a road, and it's going to go from 500 to 550. So you have that abstraction of its location in the system. So the other part of linear referencing